This module 4 and module 5 of this data science have some correlation, because module 4 is simple linear regression and module 5 is multiple linear regression. So far I have taught you what is regression. Regression in the sense it is a mathematic to predict the future outcome of something. Normally in business point of view it will be sales, it will be expected stock outcome and everything. So we want to predict the outcome of something, we are going to use regression for it. So can you see this cartoon and say what they are speaking? That means everyone will be keen in knowing about the future. So if there is a math to know the future, then it is welcome. Yes or no? So this is the cartoon, and this regression will have a line equation that could model the feature. That means these are all the data points accumulated on the feature space, and there is a line segment that could generalize all the data points so that you can predict the future outcome of it. For example, what do you infer from this? The monthly sales is increasing in a gradual manner. When the online advertising goes on increasing, the monthly sales is also goes on increasing, so that it can be predicted using a line equation. That is the inference that you should take from this slide. And let us go to the slide. So these are all variables. There will be variable 1 and variable 2. So what will be variable 1? When there is a Christmas, cake sale will increase. Yes or no? When there is a season of Christmas, the sales of cake will go on in an increasing curve. And then when there is a BS4 to BX6 conversion of the vehicle, then the car sales will get increased. So these are all some of the variables that have influence over other variable. Do you infer the variable 2 is a kind of a monetary variable here? Everybody? Sales, selling item, stock market. So everything is associated with the monetary fund here. So what are all the variables that are linked with respect to monetary variable? We are going to see this. Other than that, we will be studying what are all the customer behaviors that affects the order pattern of Swiggy and the network traffic and the purchase pattern of customers. So how they show the impact towards the monetary benefit of a business guy. We will be studying in this. And this regression always comes up with the proper line is nothing but we need a proper line equation. Do you know that we can understand line, but how computer can understand line? Computer can understand line with respect to only line equation. So what is the line equation? Y is equal to mx plus c. M is the gradient, so that is m. And then this is the, what is the line equation here? M is a gradient is nothing but height versus width of the line. This is the height and this is the width of the line. And then what is C? C is y intercept. So these are all two changeable parameters, tunable parameters, so that we can draw on the data points. On knowing the y intercept and on knowing the gradient, we can draw an exact line equation on the data point. For example, if height and width, if height is equal to 2 and width is equal to 4, then m is 1 divided by 2, that means 0.5. So we can substitute 1 divided by 2 here. And what is C here? C is y intercept, the exact portion where the line touches the y. Here, what is the exact portion where the line touches the y? 1 is the point. So we will be writing 1 here. So once again, I am telling you, these are all the parameters of the line. We human can understand line, but computer understands line by only knowing the line equation. What is the equation of a line? It's an old school math. Y is equal to mx plus c. M is slope. What is slope? Height divided by width is the slope. Do you agree with me? The area is very slopey. That means the height will be, then height and width will be involved in it. So height divided by width is the slope. So we are going to change the slope and the y-intercept C. That means the line which touches the y-axis, so that we could fit an exact line on the data point here. What is a data point? Data point is the distribution of some features. For example, this is a data point, right? This is the distribution of feature between online advertising dollars and monthly sales. And there is a formal definition for regression here. Regression searches for relationship among variables. As I told you, these are all the relationship among variables. When the Christmas season comes, the cake sales gets increased. And when the BS4 vehicle gets converted to BS6, then it will show an impact on car sales. Then, as I told you, the regression searches for relationship among variables. And this regression analysis is one of the most important fields in statistics and machine learning, because you are given power to say the outcome, what it will happen. And for example, you can observe several employees of the company, and to understand the sales depends on the features like experience, level of education, role, city of working, and etc. and so on. So these are all the features that shows impact on a particular monetary outcome that we will be studying in regression. So these are all the data points, and these are all the regression line that we will be fitting in. And to say regression in other words, you need a function to map the features. Here, what is the function to map the features? Line equation is the function to map the features. Why we want to map the features? Because we want exactly to know the outcome of it. So there are two kinds of features with it: dependent features and independent features. Now, you please tell me what is a dependent feature here and what is an independent feature here? Which feature is dependent and which feature is independent? The online advertising because the monthly sales depends on the online advertising of dollars. Yes or no? So there are two kinds of features: dependent features and independent features. And dependent features are called dependent or output or responses, because here we call it as dependent feature. Why so? Monthly sales always depends on how much you are advertising. So monthly sales comes under dependent feature and online advertising comes under independent feature. In other words, we can say, well, the feature in y axis comes under a dependent feature, and feature in x axis comes under independent feature. Do you agree with me, guys? What is dependent and what is independent feature? So this will have a sort of prime importance here. And it is a model between dependent and independent features. That is a regression model. And this is a proper mathematical equation for a regression model. That means you are going to estimate something, that the thing that you are going to estimate will come in y-axis. And this is an exact equation of a line. This is y-intercept, and this is slope, and this is slope, and this is independent variable. That means in x-axis. And this is error term. Error term says the difference between the data point and the line segment that you are drawing. That you call it as an error segment or error term. That means it is a kind of accumulated difference. That means an add-on difference. That means the difference of this point to the line segment, difference of this point to the line segment. It is an add-on difference between the data point and the line segment. We cumulatively call it as error function. Hope we might be studying in regular class. Now guys, are you clear what is an error function? So equation of a line can be modeled by y equal to b naught plus b1x plus e. Y is the thing that you want to predict. Here, what is the thing that you want to predict? Monthly sales. Let us assume that this as y, and then this is b naught. B naught is nothing but the regression intercept. This is b naught. This is regression intercept, or you can call it as y intercept. B1 is the slope, that height versus width, and x is an independent variable. That means this value is x, and e is an error term. That means sum of difference between all the data points and the line segment. This point and the line segment, plus this point and the line segment, plus the third point and this line segment, plus the fourth point and the line segment. So what are all the difference between the data points and the line segment? We aggregate it, or we cumulatively call it as error term. And one of the most important error is least square error. That means this is y dash. Y dash is nothing but the predicted value for y, and what is the observed value. For example, let me tell you, if a student is scoring 60 out of 100, we expect him to score 100 out of 100. Now he is scoring 60 out of 100. So the expected outcome is 100 out of 100, but the observed outcome is 60 out of 100. What is the error value here? The error value is 40, because the expected outcome is 100 out of 100 and the observed outcome is 60 out of 100. Now the error value is 40 here. Likewise, that is the method of least square is the difference between the predicted value of yi and the observed value of yi. And once again, let me ponder around one of the most important equations. Once again, it's a line equation. You should know what is dependent and what is independent variable. It is an outcome. Outcome is always a dependent variable. For example, it might be a monthly sales or a stock outcome or anything. And this is a dependent variable, because x is an independent variable. Why x is an independent variable? This x influences y, and so that the y value changes off. For example, in this equation, this is x value. This have influence over the y value, because only when you increase the online advertising, the monthly sales will get increased. Now we call it as independent variable, and this y-axis we call it as dependent variable, because monthly sales always depends on the advertisement that you are going on. So x will always have a proper influence over y. So x we call it as an independent variable. As y is influenced, we call it as dependent variable. And this is the need for regression. To forecast a response, we go for regression, and we study the relationship between several variables here. That is the need for regression. And regression model, the relationship between variable, where the change of variable may explain some influence over the y-axis. And regression estimates the nature of relationship between dependent and independent variable, how strong or how they are correlated, and change in dependent variable results from changes in independent variable. As I told you that if you change the month, then the sales of the cake may get variation, especially in terms of December, the sales of cake may get increase. So there is a correlation or a relation between those two variables. So in regression, we are going to study about the strength and relationships of variables, and what are all the statistical significance between those variables. And bivariate or multivariate model. So far we are studying about a simple regression model. That means there is a single variable that have influence over the y-axis, like this. This is a single variable. Online advertising in dollar is a single variable that have influence over y-axis. That means the monetary sales. But in multivariate or even in bivariate regression, we go for multiple variables that have influence over y value. For example, a person's income is based on experience, age, education, etc. So as there are multiple variables contribute to influence over Y, we call them as multivariate model. Here there is a single variable that influence over Y, we call it as simple linear regression model. And now let me tell you what are the difference between simple linear regression and multiple linear regression now, and then we will proceed towards a working model. So you should be knowing the difference between a bivariate or a simple linear regression model. So in case of a simple linear regression model, there is only one feature that contributes towards the dependent variable. Here, in case of bivariate regression model, there are two features that contributes towards a regression model. So once again, this equation is very important, and this only using this equation you can fit a line. And this is the regression line, and x and y are obtained from the sample. For example, what is x here? X is an independent variable and y is a dependent variable here. And b naught is nothing but y intercept, and b1 is the slope, and e is the error term, as I told you. And relationships might be of historical studies, correlation and cautions, and speculations about a particle and a particular relationship, etc. And use of regression. Use of regression is only to increase the business curve of people. That means to predict something and to learn something from the prediction model and how to act. That means prediction and forecasting of scale of sales and economic growth, etc. This is one of the prime needs for the regression model. And based on the hours or a week that a person is working, his income is getting varied. And this is an example for a single regression model. Based on hours per week, the guy's income is getting changed. See, for example, if a guy is working 50 hours per week, his income is higher. If a guy is working 40 hours per week, his income is comparatively lower than the guy who is working 50 hours per week. So, can we model the relationship between hours per week and the income now? Placing the data on this graphical or a Cartesian coordinate system comes under exploratory data analysis. Rather than textual or a tabulation form or numerical data, we can visualize data here. This is known as exploratory data analysis. You can see how a line is being fitted here.